Well, dear, welcome back. So, today I'm going to discuss a very interesting story or fact, whatever you may call, um, introducing ChatGPT as my new TA for robotics course. You know, of course, this is the example I am taking from robotics course, but I'm sure for all the courses this can be done. So I'm a little bit humble right now and scared also for introducing ChatGPT as my new TA. But in future, it may be new faculty, right, for teaching or instructor for teaching robotics. Oh, that will be good. I will be a little bit philosophical at this stage. Okay, I think, oh, there is no substitute for classroom teaching, blah, blah, blah. But the fact is, ChatGPT can do a lot of job in future if it is trained properly as a subject instructor. Okay, and maybe it is good and I will have a lot of other time spare time for doing research. So I was spending couple of hours exclusively on solving some of the basic robotics problem, and of course this lecture video needs that you know or you have undergone mathematical foundation of robotics or introduction to robotics course. Um, but even if you do not know, I can just try to tell you the um, fundamentals about some basic problems which we solve and we teach our students, and that now ChatGPT can help giving assignments, giving coding exercise, and all kind of things. So I was just a little bit mm, spending time, and you see. mm Even I was asking it to write code for tooling robot manipulator. It logic wise, it read absolutely correct. And then I asked to write code for industrial robot Puma, programmable universal machine for assembly. Well, it was trying to do it using Dinavet-Hartenberg principle, and after some time, it stopped. But next time, again, when I asked the write Python codes for solving inverse kinematics problem, which is not very trivial, as you know. Normally, at the end of the semester, we just ask student to derive, um, or middle of the semester to derive inverse kinematics. But within 30 seconds, it was trying to write the code successfully. Second time, it wrote successfully. And let us see all this story. Let us go to ChatGPT now. And, here is ChatGPT, as you know. So on November 30th, of course, it was introduced. In my earlier video, I have told that what is the kernel of ChatGPT is a language model, but it is you can chat with it. So conversational mode, you can use it. And since it has intelligence and amazingly, it is taking some of its own decision. Let us see how um, skillfully it can do its job. Okay. So I was trying to solve a couple of fundamental robotics problem using prompt. And that is through prompt, I was asking question that how to solve inverse kinematics problem for a manipulating robot. Okay. And what is inverse kinematics, forward kinematics? The robotics course who has undergone already know. But even if you do not know, say manipulating robot is just like my hand. Okay. So we train our students how to model hand like robot. Forward kinematics is the model when you write, when whimsically I move the joint, and as a result, my end effector, this is called end effector, means end point, my wrist. As a result, wherever it reach, that problem is called forward kinematics. So basically, it is a Cartesian space and joint space. Joint space means this is joint space. Cartesian space means where my hand is moving. So when the mapping between joint space and Cartesian space is linear, means if I move my hand uniquely, my end effector will reach somewhere. That's the forward kinematics problem. An inverse kinematics problem is I asked my hand to reach somewhere. I specify this is an input X, Y, Z, alpha, beta, gamma. Okay. Then robot need to know, or my hand need to know how to reach there. And this is called inverse kinematic solution. And of course, those who do not know, this inverse kinematic solution, the mapping between Cartesian space and joint space are nonlinear. Why? Because for reaching here, there are so many different arm configuration. Even I can move my hand like this. So the solution is not very trivial, and we need to do some kind of optimization also. All feasible solution mathematical model will give you. So I am trying to ask ChatGPT, this is my prompt, how to solve inverse kinematics problem for a manipulating robot. And what he wrote, inverse kinematics is the process of determining joint configuration of a robot required to achieve a desired end-effector position and orientation. Perfect. In other words, it is the process of finding the joint angles of a robot that will cause its end effector to move to a specific position and orientation in space. Perfect. Same thing it is trying to write more clearly. There are several methods to solve the inverse kinematics problem for a manipulating robot. Here are some common approaches. So these are perfect. Analytical solution. So this solution we derive in the class. Okay, geometric solution we teach in the class. So analytical solution, it is telling the approach involves solving a set of equation to determine the joint angle required to achieve a desired end effector position and orientation. So this method is often used for simple robotic manipulators with a small number of joints and a regular kinematic structure. Perfect. Whereas geometric solution, it is writing, its approach involves using geometric method to determine joint angles required to achieve a desired end effector position and orientation. This method is often used for more complex. You see, it knows now what is more complex, what is simple, or maybe it is retrieving facts. Okay, but it is doing it beautifully with a large number of giants and non-regular kinematic structure. The numerical solution, of course, when it is redundant robot, means when robot has many joints which is not required, just like our hand, then getting kinematic solution is very difficult. And then my students know, or if you do not know, my lecture video uh, clearly, perfectly tells you what are the different numerical solutions in the class in the robotics lecture of humanoid robot. So there are so many algorithms which is written, but here it is telling correctly numerical solutions where to use. This method is often used for robot manipulators with complex kinematics that cannot be solved analytically or geometrically, right? Then optimization based solution. This approach involves formulating the inverse kinematics problem as an optimization problem and using optimization technique to find the joint angles that minimizes a cost function. This method often used for robot manipulators that have constraint on their joint angles or means obstacle avoidance. Say my hand need to move here, okay, but all on a sudden there is some obstacle here. So my hand need to figure out a different solution. So that it also writes, right? So this beautifully it wrote. The choice of method depends on the complexity of the robot manipulator and the specific requirements of the application. In practice, a combination of methods may be used to solve the inverse kinematics problem of a manipulating robot. Okay, as a beginner, what else you need? So now let us see if I ask it, write Python code for a two-link robot manipulator. Let us see what it is doing. Um, So it code processor inverse converter of a tooling robot manipulator using geometric approach. So it wrote beautifully. This and intuitively in the class also we do that L1, L2, they has to be assigned some values, length of the link. Okay, one it has. Okay, end effector. Okay, then see what it has written. Okay, okay, one. So the solving the theta one. Okay, um, and theta 1, 8 and 2, in terms of 8 and 2 function, it wrote. Okay. So this is the correct solution it did actually. And I can, um, but the other time I asked it to solve, it solved in a different way. This time also different way, but it seems correct because theta 1 in terms of 8 and 2 function, I have defined xy and k1, k2. These are the parameters which means derived parameters in terms of link length only. So they are correct. Okay. And the variable is theta 1 and theta 2. Okay. So I can very easily understandable. Okay. Define the link length and this is the geometry. Okay. Theta 1, theta 2. So it uh, wrote the code and one can just take the codes and put it in the Colab or somewhere else and you can see whether uh, giving some specific value of x and y, whether it gives you correct theta 1 and theta 2. And since the logic is apparently is correct, it will give you, okay. Uh, I think so. So um, this is what uh, ChatGPT can do. So next time, being inspired, I also asked how to apply resolve rate control for a manipulating robot. Then it is telling, you see, resolve rate control is a method for controlling the motion of a robot manipulator by specifying the desired end effector velocity instead of the joint velocity. So basically, suppose I would like to make a trajectory with certain velocity and I define it in the Cartesian space and there is a method we teach you. We have already taught you in my course, the video lectures, right? That how to calculate the uh, joint velocities and the mapping matrix, as you know, is Jacobian matrix. It's called Jacobian matrix. Okay. So it is telling beautifully all the steps. Here are the steps. Okay, resolve rate control. Now, how to control means I am specifying Cartesian space velocity with the trajectory, and it required to resolve using Jacobian the joint space velocities. And again, in a loop, you need to run the control loop. Okay, so it is writing. Determine the desired and effective velocity that can be specified based on the desired trajectory of the end effector. Okay, then compute Jacobian matrix. Eh? The Jacobian matrix relates the joint velocity to the end effector velocity. It is computed using the kinematic parameter of the robot and the current joint configuration. So these all known to you, right? And these are very simple but fundamental robotics class we teach and you know now. So inverse Jacobian matrix, then it is talking about singularity. When you are calculating inverse Jacobian, then for some configurations, the determinant of the Jacobian matrix may not exist. And then those configurations are called singular configuration. So those also it told. And not only that, it told resolved control can be implemented using various programming languages and robotic middleware such as robot operating system or ROS. It is often used in applications that require robot to move at a specific speed or perform tasks that involve motion planning, such as pick and place operation, assembly task, welding applications. Well, it gave me the answer. And then I also asked, um, write a code for resolved control, and it wrote. I will show you. Okay, okay. Calculate by. Okay, so here it is. Here is an example of Python code to calculate similar configuration of the tooling robot manipulator. So I asked, write Python code for calculating singular configuration of tooling robot manipulator. So it wrote, okay, it explained also. Okay, in this code we first, and I need to check this code. Logically, it is apparently it is correct. Okay, and if it is not correct, we can correct it. In this code, we first define the joint velocities, joint variables, theta one and theta two. Okay, or q one, q two, and kinematic parameter, that is link length. We then define Jacobian J for the robot using the partial derivative of the forward kinematic equation. That is very simple. We do in the class and in my lecture. And finally, we compute the determinant of the Jacobian matrix and check if it is zero. If the determinant is zero, the robot is in a singular configuration. And if it is non-zero, robot is not in a singular configuration. So ChatGPT ChatGPT knows about singularity. Okay, and it told me about this. Now, more interesting thing I will tell you. Um, when to apply resolved control and when to apply dynamic based control for manipulating loop. Huh? This is another tricky question I gave, but before that, I need to tell you that while mostly resolved control we do, but when robot need to interact, instead of picking and placing in a free space, when it need to interact with the environment, for example, painting, cleaning floor, when end effector is touching the environment, then um, or maybe it is doing uh, along a trajectory some kind of surgery, brain surgery. So Da Vinci robot, for example. So all this special application require inverse dynamics problem. Uh, how to calculate inverse dynamics? So that's why I asked GC Nandi asked how to calculate inverse dynamics problem of a manipulating robot, and my TA answered correctly. So inverse dynamics, what is inverse dynamics? It explained. Okay. It is calculating the joint torques required to achieve a desired motion of a robot manipulator. Perfect. It is an important problem in robot control, an inverse problem, and involves solving equation of motion of the robot. Then it gave the detailed steps, so you can read it. Okay. Um, and this is perfect. Yeah? And not only that, uh, also when I asked now mm, some tricky question I asked, mm, when to apply resolve rate and when to apply dynamic based control for manipulating load. So interestingly, it told the fact. Okay, so these are fact. Maybe it is collecting from somewhere and giving you, but the way it is assembling them, the way it is giving you, it requires intelligence. Resolved control and dynamic based control are two different approaches for controlling the motion of a robot manipulator. And after reading this, mm, things will be very clear, right? Then also I was interacting with it. Can you solve forward kinematics only and use it for inverse kinematics with machine learning algorithms? Okay. And when machine learning was not, algorithms were not very um, sophisticated, even then, because of our computation power, even in 1994 5, I remember in the 90, my previous institute, one of my enthusiastic student, I think if I correctly remember his name, Sumanto, right? I gave him this task, okay, and now, um, yes, it is. So we are trying to figure out alternative method of cranking out inverse kinematics using forward kinematics. Why? Because forward kinematics is linear problem. Okay, where mapping between Cartesian space and joint space are linear in nature. Whereas inverse kinematics is a the two space are nonlinear, meaning you have multiple solution for a same Cartesian space value uh, in the joint space. Very intuitive also, right? You see, uh, if mosquito is biting on my nose tip and my hand goes there, so this is the inverse kinematics problem in robotics, right? So this is given, my hand has to go, and in which way it should go, like this or like this or like that. So many solutions are there, or like this. Okay, so this is nonlinearity because nonlinear equations are there, so many solutions are there. So we were trying even then that how to exploit inverse kinematics to crank out forward using forward kinematics to crank out inverse kinematic solution, and it gave today's state of the art. Means the forward kinematics based inverse kinematics method has several advantages and how it can be done. And by the way, very recently again, it's an active area of research, and people have done so many work still for a six-link industrial robot. This data-driven, machine learning-based inverse kinematics without solving inverse kinematics is a difficult one. We gave another new approach in AAAI, renowned conference last year. It was in the workshop, of course. Because we could solve tooling robot manipulator using inverse neural network, uh, inverted neural network, inverted neural network. Okay, that paper is there in my website. So it is an active area of research, and it is telling that okay, if I generate data using the linear model, and that data I can use for developing a machine learning based algorithm, support vector machine, or some other machine, other algorithm, it can solve actually. Okay. Then I also asked, can we solve forward dynamics only and use it for solving inverse dynamics with learning? And then I just twisted from forward kinematics. I told I will only solve forward kinematics, and uh, then from there, I solve forward dynamics, and then using the data, I will solve inverse dynamics problem the way we did it for kinematics. But immediately it understood, okay, because I will have to write forward dynamics equation, okay, because forward kinematic equation has only, as you know, only linked length. It doesn't have mass, uh, inertia, and friction, and it knew. And so the way question answering it is doing so far, it will get A plus. Okay, definitely. So what it is writing, it is not possible to solve inverse dynamics problem directly from the forward kinematics equation. The inverse dynamics problem requires knowledge of the robot's mass distribution, inertia, and frictional properties, which are not captured in the forward kinematics equation. Yes. Therefore, it is not possible to use a learning based approach from forward kinematics alone to solve the inverse dynamics problem. However, it is suggesting also it is possible to use forward kinematics equation to estimate some of the parameters required for solving the inverse dynamics problem. For example, the forward kinematics equation can be used to estimate the end effector velocity and acceleration, which are inputs to the inverse dynamics equation. And additionally, machine learning algorithms can be used to learn the relationship between the joint torques and the joint angles, velocities and acceleration, which can be used to improve the accuracy of the inverse dynamics solution. Not only that, it is telling that the advantages and disadvantages of mm, um, analytical solution versus data driven solution, when, where it should be appropriate. So you can read the chat GPT's answer. Definitely, it is a good one. Hmm. Then also, uh, being encouraged to see that its coding competence. I just asked it to write Python code for tooling robot manipulator, and it wrote correctly in terms of it and two function, not in terms of arc function. Okay, the way we write. Okay, so I also asked write Python code for solving inverse kinematics problem for Puma type of industrial robot. So you see, humbleness as a AI language model, I do not have access to hardware or software to test and run uh, Python code. However, I can provide a general approach to solving the inverse kinematics problem for a Puma type industrial robot. Okay, it has six revolute join, blah blah, all kind of thing. So and its inverse kinematics can be solved using analytical method. The forward kinematics equation can be expressed in terms of the joint angles. Okay, and all, and then it started writing the code. See, link lengths. It was taking in meter. Okay, that's how it should write. Okay, then it was trying to write code using, this is actually, the um, um, matrix, homogeneous coordinate transformation matrix between 1 and 0, then 2 and 1, 3 and 2, 4 and 3, 5 and 4, 6 and 5, like that. Okay, so that the way we do in the class, right? And then it stopped somehow. So maybe it thought that it is getting, and it must, why I have given, because it is not very trivial. It takes a lot of space, a lot of effort, and it is trying to do within 30 seconds on maximum a minute. Then it was thinking a bit, and then um, it couldn't do actually. Then after some time, I gave uh, write Python code for solving inverse kinetics problem Promotype of industrial robot. And where is the code? No, this is not one. Um, so maybe we can give, okay, write Python code for solving kinematics problem of human robot. Okay, write Python code for solving inverse kinematics problem of human robot. Let me see. Um, this time it is, you see, it has simplified the problem. It has taken the geometric approach, and um, instead of 6 degrees of freedom, it is now three joint. It has reached 4, 5, and 6, which are actually intersecting at a particular point, as you know, and then it actually wrote the code, and somebody need to, we can actually easily um, debug the code. You can run in the Google Colab and actually debug the code whether it's correct or not. And once also, it interestingly, it wrote, I would like to show you the solution for using uh, without um, mm, reducing the degrees of freedom of the robot. Okay, for practical purpose you can reduce, but then you get approximate solution. Okay, so it gave me the answer anyhow. Okay, So singular configuration, I already told you, and it is, and then some physics question also I asked, can you analytically solve simple pendulum problem? Hmm? And it wrote the code. This is for uh, 12 class students, those who know. Eh. And it wrote also the physics, you see, and that um, mm, actually getting the kind of the analytical solution for simple for pendulum is very difficult. Then we make it simple. That means the assumption also it wrote it- pendulum is massless and the mass is concentrated at the point of the end. There is no friction of the air resistance. These are my assumptions. Without that, you cannot solve. The displacement of the pendulum is small, very small, less than 10 degree. And you now all know, but in 11th class, I think, when pendulum dynamic equation is first introduced, it is very amazing and to do the experiment that using only 10 small oscillation, you can use the time period, and if you make the oscillation big, the calculation from the time period from this model will be something, and actual time period will be different because you have violated this. So this constraint also, assumption also it gave. Then it wrote the equation, analytic equation, and then it actually solve. In this code, we have first defined the initial condition of the parameters of the pendulum, including initial angular. So even the physics problem, it tries to solve. So, so what is take home? Take home is, you see, for semester long mathematical foundation of robotics course, we teach right from the fundamental um, how to model a robot, okay, detail about the matrices and all kinds of things. We talk about homogeneous coordinate transformation matrix, Jacobian matrix. Then we also tell you dynamics, and then we talk teach control. Apparently, ChatGPT, at least as of now, can help me as my TA, and I don't see any problem because students. Um, the problem I can give, ChatGPT can give some solution. To student can debug the codes, and right now that much it can do. And as the time will pass, the recipes are there. Everybody is working how to make it smarter and smarter, and give your feedback and try to make smart means uh, it is if it is making some mistake, if I can capture the from which source it has collected that information. So it is collecting information from some web browser, some in the net, and then it must be having some arithmetical or calculator access. It must be having some dictionary kind of thing. Okay, so all this uh, things which from where it is collecting information, if we also can correct, and I don't see ChatGPT after all. What are the TAs they do? TA one course we teach them, second time they become TA and then they go. But at least ChatGPT will be a permanent TA. Huh? How about that? And not only that, you can teach any course. Okay, using ChatGPT. Mm, uh, See, I was asking it that what are the different types of data structure, okay, we use, and we can solve many problem. It tells. So my query was, how many different data structures are there in computer science? It was very, very vague. Yeah? And then it wrote, there are many different data structures in computer science, each designed to store and manipulate data, store and retrieve and manipulate data in a specific way. Some of the most commonly used data structure includes array, linked list, stack, queues, trees, graphs, hash tables, heaps, sets, maps, blah, blah. So all semester course you teach, so it is also able to uh, help you in solving some code also, problem also. to demonstrate each of the data structure. So I don't see any problem right now. ChatGPT is becoming a unpaid PA. How about that? So I don't know in future things are scary whether it will replace me. I don't know. But right now I'm philosophical. Oh no. Teachers are necessary. Classroom teaching is necessary, and I want and I wish in future it will be like that. But nevertheless, it is amazing. I am just having fun with you guys. So it is amazing. I thought spending some time with robotics course with ChatGPT mm, gave me enough opportunity to know about ChatGPT, what it can do, what it cannot do. What it cannot do also, maybe after some time it will be able to do. So, in short, um, we are very hopeful about the capabilities of the ChatGPT and the future teaching, learning process, code writing process will be far more superior. And with this, I say you goodbye and stay tuned and make friendship with ChatGPT. Extract as much as possible from its capability and devote more and more time on actual research, actual thinking process. Okay, best wishes. Have fun. Bye bye.